Hi everyone, welcome to Foundry Live. My name is Joyce, your virtual host for today. Just to let you know, today's webinar is recorded and will be available as on demand when the event finishes. In today's session, we will be covering what we've been working on here at Foundry within research and innovation by Director of Product for New Technology, Mathieu Mazerolle, and ending the session with a Q&A, taking questions from all of you guys. So please make sure you throw in your questions in the questions tab. We are celebrating Foundry's 25th birthday, and Foundry Live is part of our celebration, along with showcasing some of our key milestones from where we've started to where we are now. Foundry was founded back in 1996 by Simon Robertson and Bruno Nicoletti. Finding and creating innovative solutions with extensive research and development in our products have been our bread and butter. And I'm sure, as I'm sure you've heard in our tagline, Imagination Engineered. In 2006, we received the SciTech Awards for our Furnace plugins. In 2013, Project Dreamspace was launched, exploring the evolution of real-time filmmaking. In 2018, Nuke in the Cloud was part of the production for The Crown Season 3, and in 2021, we launched machine learning in Nuke. So many things to celebrate, and you can see all of these milestones from all of our product on our anniversary page, which will be shared in the chat shortly. We're going to continue our celebration with Foundry Live. We started off with our look development and lighting session on Tuesday and our Nuke session yesterday, and both are now available as on demand. On the 28th of September, we have our Flick session, the future of flicks and story development, and ending our week with Modo, the completed Modo 15 series on September the 29th. And I hope you can join us for these as well. Stay up to date with us. We have a dedicated page for insights, sharing case studies, trends in the industry, and artist spotlights. So definitely make sure you shed an eye on that page, and of course, follow us on social media as well. We are also going to be part of View Conference, Spark Animation, NVIDIA GTC, and the Real-Time Conference. So if you're planning to join these events, make sure you join our sessions as well. We have a dedicated page for our learning material and training materials in case you are looking to brush up your skills or to expand them. So make sure to pay a visit and have a look at some of the great content that we have. We also have Victor Perez's Color Management Training Volume 1, which you can watch for free. We have a range of roles available here at Foundry if anyone is interested. They range from marketing to product and engineering. So for more information on the job specs, visit our careers page. We want to call out a special thank you to our partners, Dell and NVIDIA. Not only have they been supportive of Foundry Live, we have been working closely with both companies to test and optimize our software with their products. So we're really excited to give away an RTX Quadro 5000 and other prizes. If you are opted in when registering for Foundry Live, then you don't have to do anything, just sit back and we'll be in touch with the lucky winners. We're also giving away 3 digital Nuke books. Again, you don't have to do anything, and we will contact the 3 lucky winners. And a massive shout out to Daniel Smith, supervisor at Crafty Apes and author of this book, Nuke Codex. I'm sure some of you have seen this already in your inbox or you've seen this swimming around. We've recently launched our annual Nuke survey, and we would love to hear from you and get your feedback so we can continue with our Nuke roadmap. So if you haven't had a chance yet to fill out the survey, now is a chance, and we will make sure to drop the link for the survey in the chat. Our virtual events wouldn't be anywhere without the amazing studios and the artists that we've been working with. So thank you so much for using our platform to share your stories, your projects, and all of your industry insights as well. And really looking forward to building many more stories in the near future. And that's enough from me. Thank you again for joining, and I'm going to hand over to Director of Products for New Technology here at Foundry, Mathieu Mazerolle. Over to you, Matt.
Hi, everyone. Just going to share a couple slides with you before we get into things. So thanks, Joyce. Welcome and thank you all for being here today. So I'm Matt Mazerolle and I work in Foundry's research team. The research team is a group that's dedicated to exploring new creative workflows that are slated for meeting the challenges of the future. And we're organized around three main areas. Cloud, where we're exploring scalable compute and distributed data management. AI, where we're exploring machine learning, creation of force multiplying tools, and the elimination of repetitive work. And real time, where we're looking at real-time technologies and virtual production. So today, I'm going to bring you up to date on our work in each of these areas and give you an update since our last Foundry Live presentation in March. And then we'll have today's main feature. It's going to be an exciting panel about the convergence of real-time technologies and visual effects workflows. And that'll be featuring Ari Rubenstein, Indy, Matt Jacobs, and Shahin. You'll hear plenty from them during the presentation and hope you enjoy it. Also, keep your eye out for an exciting showcase of Foundry's virtual production techniques at the Real-Time Conference in November. We're planning something really exciting and you're not going to want to miss it. So with that, let me start with giving you an update on some of our recent work. So, just stop right there. One of the effects of COVID pandemic has been the acceleration in the use of cloud technology. But this has posed some new challenges and some new opportunities. Foundry Cloud team is focused on making use of the cloud easier and more practical. And the key challenge to solve is getting the right data in the right place at the right time. Foundry's cloud team is working on two projects in order to make this happen. The first is data manifests. Data manifests is a system that allows pipelines to bundle exactly the required files and metadata for a given task or workload. What you're watching here is a demo of an internal prototype that we've built that uses data manifests to upload data from Nuke to AWS to train a copycat machine learning model in the cloud. Another challenge when leveraging the cloud is asset resolution. Hard-coded paths don't work when files move around or when you have metadata coming into play. For this, we're working on a project called OpenAsset.io. OpenAsset.io is an effort inspired from Katana's excellent Asset API to make asset resolution generic and cloud-friendly. OpenAsset.io is not only for Foundry applications, but for anyone at large. We're actively collaborating with several industry stakeholders to help bring OpenAsset.io to a level where it can stand on its own as an open source project. So if you're interested in working with us on this, then please drop us a note in the chat and we'll be happy to get back to you. In Nuke 13, we introduced Copycat. Copycat lets you train your very own machine learning model. Provide Copycat with a small number of before and after images, and it'll learn how to generalize the effect between them. Copycat can be used to intelligently apply that same learned effect to any footage that you desire. For Nuke 13.1, we've been working on ways to make machine learning even more extensible. Now, you can use Nuke to work with any machine learning model that uses PyTorch. PyTorch is one of the most popular machine learning frameworks out there, and many of the most exciting machine learning models on the cutting edge of academic research are based on it. With Nuke 13.1, you can wrap a PyTorch model in a CAT file, which is the same file format that Copycat uses, and feed it footage through the new inference node. What you're seeing here are some examples of popular machine learning models from academia that do style transfer, image segmentation, and a lot more. Stay tuned for the 13.1 release to try out this new flexibility in Nuke's AI toolset. We're really excited to see how this is going to be used out in the wild. Foundry Research is also focused on opportunities for streamlining workflows by means of real-time technologies. The capabilities of GPUs and game engines continues to increase by leaps and bounds. And this is enabling faster turnaround in the creative process and blurring the lines between pre-production, production, and post-production. We've heard from a lot of users about how real-time tech, like Unreal Engine, is great for speed of iteration, but also that it can be challenging to bring these tools into a pipeline where compositing and visual effects techniques also play a role. So that's why we're excited to be releasing a new feature in Nuke 13.1 called Unreal Reader. Unreal Reader provides a slick, compositor-friendly workflow for projects that have Unreal Engine in the pipeline. Here, a live Unreal session with sample content from the Unreal Marketplace is connected to Nuke through the Unreal Reader node. We're able to isolate passes, remove occluding objects, generate utility passes like depth, normal, and cryptomat, and do some more advanced things like render cube maps, tweak Unreal variables, and tune the camera position. We did a deeper dive into the Unreal Reader node in our Foundry Live Nuke session. And if you missed that, the recording is available. You can check the chat and the link should be there. So that brings us to our main event, which is our panel on real-time workflow in VFX. The panel brings together some of the early beta testers of Unreal Reader to talk about how they've put real-time technology to work on recent projects and how they think that this type of workflow is going to evolve in the future. We've pre-recorded this panel and edited it slightly for time, so feel free to ask questions while you watch. We'll have some time for a live Q&A with the panelists at the end. And by the way, the panelists featured here are also in the chat, so feel free to ask questions, and we'll be happy to be shooting answers to you as we go along. So without further ado, here's our panel on the convergence of real-time tech and visual effects, and stay tuned for the Q&A after.
Hi, everyone. Thank you for joining me today, this panel about the future of visual effects and real-time. As you know, visual effects is being transformed by the introduction of real-time technologies. And this has really been accelerated over the last year and a half or so by the introduction of Unreal and some of the big shows that have made use of LED stages like The Mandalorian. And this has caused a lot of discussion and a lot of talk about how do we integrate the capability of real-time technology into the processes that we use to produce content in all kinds of different forms. We're really excited by this trend, and we've been here at Foundry, we've been collaborating quite a bit with our customers in the industry to understand how we can leverage real-time technology and bring it more easily into the hands of creatives so that we can have better pipelines and just bring better tools into the hands of everyone. Part of that process led us to develop a brand new tool that we began to incubate late last year called the Unreal Reader node. The Unreal Reader node is a really exciting new feature that's coming in Nuke 13.1. And if you want to get all of the details on that, I encourage you to go check out the Nuke session on Foundry Live, where my colleague David Nolan will go into a lot of detail about the Unreal Reader node. But for today, what we've done is we've brought together 4 of the early beta testers for the Unreal Reader node. The Unreal Reader node had a really exciting beginning where one of our engineers in Foundry Research, Rebecca Sitterbaum, built an experimental integration between Nuke and Unreal. And that experiment evolved into a tool that we passed to a small number of customers and evolved over time as we saw the types of work that they were able to do by integrating Nuke into compositing workflows. So each of the people here are going to talk a little bit about how they've made use of the tool. And then we're going to have a discussion to talk more widely about the impact of real-time technology on visual effects post-production and where we think this is all going. So we'll try. So just to get started, I'll introduce each of these wonderful professionals who are with me today. I'll start with Shahin Toosi. So Shahin recently collaborated with Paul Franklin on an upcoming film called Fireworks, which is still under wraps. But Shahin did apply some amazing post-production techniques to the film in order to achieve the visual effects that are integral to the storyline for the movie, which is very great. And so Shahin will talk about that a little bit later. I have Indrajeet Sisodiya from Pixomondo. So Indy is a Unreal expert, but also with a strong compositing background, who's developing cutting edge tools at Pixomondo that leverage their use of Unreal and to fit them into their nuke-based pipeline as well. So Indy's going to talk a little bit about some of the tools he's working on, which are really exciting. Ari Rubenstein, who's here from to talk about his film, his upcoming short film, Small Blue Shadow. So Ari is a creator and a producer who works on just really amazing projects. His last film, Blues Crab, came out to great critical acclaim, and Small Blue Shadow is something where he's taken direction of using real-time technology to help realize the project. And he's really pushing the boundaries of what people are doing to use real-time technology for animated content. And Ari will talk about that a little bit. And Matt Jacobs, who is currently with Technicolor and PC, who previously, in his previous projects early this year, was working on LED stage virtual production projects where the physical limitations of the LED stage were challenges that he was constantly overcoming on a day-to-day basis on set, working with the director and the creative team. And some of the stuff that Matt has done in the trenches with virtual production and LED stages was quite interesting. And we were really excited to collaborate with him early this year and see some of the amazing work he was able to do with this emerging technique. So Matt, why don't you talk a little bit about how your projects I was with Intrepid, if I'm not mistaken, working with an LED stage where I remember when we were working with you, it was a constant struggle to try to get things out of the LED stage that were always trying to meet, the ever expanding scope of the directors on set, and trying to get the most out of a technique that fundamentally has limitations. So talk to me a little bit about how those expectations were managed, how you did that, and how you're able to also take those expectations and kind of push the boundaries with some of the techniques you used.
Okay. So I was filming last year on a stage in San Rafael at Intrepid Creative, and they had built LED volume, and it was a good sized stage. It was 25 feet across, 20 feet deep, and 14 feet high. So not one of these grandiose stages that are being built right now. And we had a lot of everything was being created in Unreal for real-time playback on the LED wall. But one thing we kind of want to do is expand our world and get kind of those, because we were treating this like filmmaking. These were all little vignettes, little short stories, things like that. So how do you capture, I think one of the biggest things we ran into is like, how do you capture your wide master shot on a small LED volume? And I think what I was quickly gleaning from the experience of the limitations of the size of the LED volume was like, okay, well, we can do the usual set extensions, right? And that's kind of where we went, and we started looking at like, how can we take, this small volume, scale it down, expand out the frame, and give the viewer that broader picture of where they are in the context of the story before you start punching in and having someone talk about either product or interaction between two actors or those types of things. So that was where we started taking the traditional route of looking at tracking the shots, set extension work, and all of those things. And I think that's where we started talking. I started talking to you guys at the Foundry about Nuke, and we started this dialogue around what could be done, what you guys are developing. And in certain cases, I think what I found was like one scenario in particular. We had a woman standing on top of a apartment building, where she'd come from inside the apartment building to outside the apartment building. I have to say it was kind of an amazing shot because all on the LED stage, and the gaffer and the DP did such an amazing job of lighting this that you felt this woman transition from an indoor environment in a kitchen to an outdoor patio. It was really quite amazing. It was one of the times where the LED and the volume really kind of blew my mind with well-crafted lighting. But off to this world, you had to see down a boulevard. Outside of that, off to the side of that patio she was standing on, and it hadn't really been quite figured out how that was going to work or what that was going to look like. But we were able to take the director, bring him into the suite and sit down with him. We had the plate, we had done some rough roto, and then we also had the Foundry tools for importing Unreal, Genio, and we were able to sit there in an Unreal scene and live art direct what was going on that boulevard, and able to really he was able to sit there and look at it and go, oh, you know what, like let's move all those buildings, like let's pull the camera over here so we see further down the boulevard, now dress that out. And we were able to quickly see the final pixel of what the ultimate image was going to be in the ultimate composition, and make adjustments, scale both the foreground, plates around, and see what our set extension was going to do. And I think that was a big eye-opener for me. It was like, wow, this is an amazing process for just that empirical approach and that interactivity that you don't get with a lot of tools and with a lot of review processes, where you're sitting there and somebody's making a picture, render the thing out, comp it, show it to the director, get notes, go back in. I mean, he was sitting over my shoulder, and he's I think he wanted to grab the controls and start moving stuff around.
Yeah, I mean, that's really exciting. That was one of the things I found really interesting when we built the, you referred to it as Genio, which was the code name for what we're calling the Unreal Reader. And to see that used as a tool to sort of accelerate that review process, but while still using, kind of well-trodden techniques like set extension, those types of things, but turn them around really quickly, and being able to do those quick rotos and comps and be able to show them in as part of a review process to iterate really quickly when you're on set and working with an LED stage was really great. And I think that that kind of helped to inform us and get us to think about how these technologies fit together. I really appreciate that, Matt. And similarly, Shahin, the work you were doing with Paul Franklin on Fireworks, to me, it was really interesting because you made use of two really out there features that we've recently put into Nuke. One is Copycat, which is our machine learning powered tool, and the Unreal Reader node. And what I always, I love Paul Franklin's work mainly because of the way the visual effects and the technology are just sort of part of how the story's told. It's not like you're watching, a film just to be blown away by the visual effects. You're always kind of drawn into the story, and then you realize there's, the visual effects magic is just kind of part of how he's telling you the story. So you tell me a little bit about what it was like to be part of that process with Paul Franklin on the film, and what led you to choose such a interesting and, I guess, sort of boundary pushing set of techniques to realize the creative vision there?
What's great working with Paul's shorts or just any Paul Franklin project? He wants to push the boundaries, and it's more about how he can tell the story and get the big emotional impact. And what he wanted to get out of virtual production here was to change the storytelling process to bring in more of to justify the character decision process is one way to describe it. If you've ever worked on any virtual production, you'll know moire, distortions, and bounce slides back onto the screen are a couple of typical things that you have to fix inside of compositing. And what I got really interested in Genio is the fact that we can bring the Unreal set into Nuke. And at the time, having Copycat, I just wanted to see how far we can push this technology and what I can get out of it. The first test that we did was to try to balance the moire effect. Since we had the camera information and some of the distortion information, we were able to just get a ground truth of what is coming out of Unreal Scene and get the actual composite and try to get Genio to Copycat and Genio to correct that for us. We also did a roto experimentations where we just literally threw the entire movie into Copycat and chose our VFX effects shots, and we did ground truth roto and see how much you can guess. As any film goes, you have back and forward cut. So if Copycat figured out the roto in one shot, it actually figured out in 20 or 30 other shots, plus the corrections. Now, what was interesting, we were doing this on a 1080 because we couldn't get any other graphics card. So we were being very, I was being very optimization driven into this process. What really came out of it was relighting. That was the part that really blew me away, and that's what I kind of delve into. There are a couple of story beats which I can talk about where we change locations in the movie, and this is just to bring the more of an emotional impact for the actors. And some of the lighting change conditions we wanted to emphasize on the character, so we painted about 10 frames of ground truth of one of the characters and get Copycat to figure it out. Now, having Genio there as well, we were able to exaggerate the amount of characters, AI actors we have in the background to complement inside of the inside of the shots. So we got a lot more out of it than we thought we initially did.
Yeah, that was interesting because one of the things I remember we talked about was, during the live LED shoot, there wasn't enough performance there to have a really kind of populated, if I don't know if I'm allowed to say, but it's kind of like a marketplace, if I'm not mistaken. And there's supposed to be lots of people, but if I understand, you re-rendered that out through the Unreal Reader node into Nuke, and essentially we're able to have a more populated Unreal scene in post-production, but still being rendered through Unreal and looking, with the same content, except with more stuff. Without the real-time constraints that were there when it was originally shot. Is that pretty much one of the things that you guys did on the show?
Yeah, we complemented the background actors. What was great because it was already the same identical scene. We didn't need to reinvent the wheel on this one. All we had to do is just add more additional actors into it and just bring it straight in through the Unreal scene through Genio. So those are the constraints that we're still learning on a virtual production. We have to recognize that we're still in the infancy of virtual production, and how the GPU technologies, I think it's like still coming along. As soon as we get over this memory limitations, we're still going to need tools to do post-production on VP.
I want to pass it over to Indy, who's working on creating synthetic render passes out of Unreal at Pixomondo using Genio.
Hey guys, so the reason why we started working on this is because initially, as I was a compositor for 7 years, did compositing. Lately, I wanted to get into Unreal Engine, wanted to explore the power of how far you can push visual fidelity with the graphics that come out of a game engine. And lately it's been getting even better and better, where every time you see the work that comes out of Unreal Engine just looks more and more photorealistic. And so at the same time, Pixomondo was building one of the biggest LED stages here in Toronto. And what happened is that while we were shooting, similar to how Matt was talking about having your tiny little world in the LED screen, but then you need more around it that is hard to visualize. But in our case, because at that time we were filming Star Trek on these LED stages, you would have a lot of scenes where like the camera really wants to be wide and really far away. And as a result, you end up having just the actual environment, which looks great through the camera. But then there might be a camera move where the camera pans up to look like, if they're like, oh, the actors have to look up, and then they all look up and the camera also pans up, but then it only goes up to a point, and then you see all the light rigs, you see all the top ceiling and the edge and all that. And so that's when I started looking into the default passes that already come out of Unreal Engine. At that time, I wasn't aware of Genio. I wasn't aware that there was a real-time tool already. So I was only like more focused on how do we extract passes out of this game engine that is not built to extract passes out of. So at that time, they had the movie render queue that was just recently released, and I could share my screen and show you guys if you guys want to see the different passes and the workflow.
Yeah, go ahead.
So basically, this was a test scene that I created in order to see different things. It's very simple. Just had a lot of different types of materials in here. So you could see we have some glass, some chrome. These back ones here are subsurface with a light that is like behind them. So you can see some subsurface going through them. Have some fog in the distance. And along with that, also have, it's an animated sequence. So you have this thing that's passing by really fast. So you get some motion blur to see if that holds up. And that was pretty much it. But then once Genio and Unreal Reader came into play, what happens is that you end up with, instead of having to do all of these manually, you just have one Unreal Reader node. And apologies, I don't have it connected because the latest build requires 4.27 Unreal, and we're using 4.26 right now. But once you have it, once you have 4.27 or the latest build, all you have to do is in here, you could just do the same thing. So the console commands that I was writing there, you could just write them here and call every single one of them the same way. So you don't have to create any renders. You have your scene just ready to go. You just can view every single pass. So the ones that I extracted were basically the ones that were useful to me were things like diffuse albedo, which is necessary when you're recreating your beauty back. Or if you have metallic items, then things that are black and white show up. Roughness maps, if you have any spec details that you want to separate, so on and so forth. And then on one side, you have all the utility passes like world position, Z depth, world normals, motion vectors, ambient occlusion, so on and so forth. So yeah, so it's actually useful. But then the biggest task was, how do I get the things that are necessary, which is reflection, refraction, because without these guys, you can't really build back to beauty. And that's something that also Genio helps, is that it gives you those options here ready-made where you can pre-customize whatever presets that you want to create. So for example, if I wanted to get reflections, what I have to do is I have to go in and I could just call my preset because I already have it saved. So let's say if I have diffuse, not reflection. So inside, once you create it, you create a console variable section. And in here, you write all these console variables one time, save it as a preset. Now you can share it around your company or wherever, project by project. So all you have to do is just lighter comes in, clicks it, and then that's it. Their diffuse is done. But now, even to skip all of this, now you could have a comp setup that does the Unreal Genio side where you have those scripts ready with those presets and console variables. So the moment you execute the Unreal Reader node, all of these flags get called.
Yeah.
However, one bigger limitation that I feel is a system-wide, as in Unreal Engine limitation, is the fact that things like reflections and refractions are based on the beauty, right? So if you were to isolate, so you could see here in my setup, I have isolated the beauty. And so right here, you can see I have, so I have diffuse plus refraction and emissives because I couldn't find ways to turn them off, like just not have them. So what I did is just found a way to only isolate emissive, so we have nothing else, and then just use the from technique to now get a pure diffuse lighting, so to speak, which you can even further break it down. If you have your diffuse albedo, you can even do the raw light kind of comps treatment. And then you could keep doing that for all the other passes, keep adding them back together. However, you could only do it for diffuse and spec and get like pure spec values or pure diffuse lighting values. However, for reflections, the way it works is that I have to render everything except for the reflection. And then from that, from the actual beauty to only get the reflections. Because if you were to go in Unreal and turn off everything, saying, hey, let me turn off diffuse, let me turn off specular, let me turn off everything so I can only see reflections, you won't see anything, because Unreal works in a different way, where unlike Arnold or other offline renderers, there is no reflection if there's no diffuse or spec to build it. So that's something that might be something to investigate in the future, where we might get reflections and refractions working. But as of now, what we do is just have the entire scene without refraction and then render the full beauty, which has everything in it. And then you just from it to get that. However, this does cause negative values in a lot of places when your values get clamped. So that might be something to look into. Also, you can extract fogs like that, which requires a lot of setup. But at the end, we did manage to get a beauty that is relatively close. It's still not 100% match, but you could see the reason being because fog
Really
also
close.
works. Yeah, the reason fog doesn't add up is because just like Arnold or other offline renderers, if you tell Arnold, let me just show me volumetric, right? It's gonna code everything black, then show you volumetric, and then your light would come through that volume. However, in Unreal, if you were to say, show me everything except for the fog, and then you try to minus the fog, it would actually be brighter, because the way Unreal would render the whole scene without the fog, the light would actually penetrate all the way to the camera, so your scene is overall brighter, which shouldn't be the case. So there's restrictions here and there that are like that, but I feel like Genio is a step up in that way, because now it allows you to get all of these passes without having to write those custom variables. You could just, your show leader, whoever is there doing it, setting it up for the first time, could just do it and pass those around. Another great thing is that you can get the camera, which is amazing, because before you would have to go into Unreal, right click, export, trying to get the camera out. And even then, a lot of times the world scene settings would be different and the camera would show up in a different place or something. So Genio helps with that as well, along with having other options where you can stencil out certain objects in Genio, which is pretty impressive, because if the director's like, you don't have to render nothing, everything is live. So if they're like, hey, we just don't want this rock in the foreground anymore, in a traditional render, you'd be like, ah, shit, we have to re-render the whole scene without this rock again. But now, because you have Genio, which is live, the Unreal Reader, you just turn off that rock from here, like from inside of Nuke, which is a very powerful thing for a compositor to have.
Yeah,
so,
indeed. This is what I found most impressive, was because, working with Unreal takes a lot of kind of clever knowledge about sort of the intricacies of how Unreal works, but then you've also got another foot kind of planted in the compositing world, where you've kind of managed to use that understanding of the intricacies of Unreal to create to generate passes and just an overall workflow where more of the control is in the compositor's hands around, you can preset the console variables, and you can give them like logical things like working in passes and isolating certain types of passes that are useful to them. So that's really cool. Oh, I see you're using the QMap generator as well.
Right. So yeah, the utilities work amazing as well. And I would recommend that people use the 4.27, because the crypto mats and all the other utility passes from 4.27 onwards are now 32-bit, which is perfect, because before crypto mats and all these other utility passes didn't have enough information to compute all the way till the end. So like you would have a clamped C depth, or your cryptos might be misselecting. But now with 4.27 and the latest Unreal Reader, you don't have to go through that issue. So I think it also helps, even if we don't get the beauty part done immediately working, just having all these utility passes on the fly for any compositor to just go in and grab, I think it is pretty impressive. So you could just go in and just start tweaking renders and relighting them. So yeah,
that's cool. But we're still trying to figure out, how do we pull all this together? And one thing I'm wondering is, now that we're kind of over the hype of the initial, inflated expectations of virtual production in LED stages, what do you guys think is what are the big problems that still need to be solved, and solved in a way that's repeatable? Ari, you mentioned saving money, and Indy, you're kind of automating the process to make it easier for compositors so they don't have to go and tweak variables in Unreal Editor. They can have a nice environment at their fingertips. So kind of at a bigger scale, what do you guys think the big problems that need to be just sort of smoothed over in order to get sort of the next level of productivity and just reusability with ththese processes. Matt, maybe you can kick it off and just be really interested to hear what you guys think about that.
Well, it's a good question. I think the first thing that comes to mind is being able to I'm gonna just gear toward LED production, right? I think the first thing is to be able to push the pictures further in Unreal, using some of what I think other people have touched on. I mean, compositing has always kind of been like where everything gets finished, right? Puts the finishing photographic touches on things. So how do we start to take that loop, go from Unreal possibly into a tool like what you've created in Nuke, and then push some of that back upstream back into Unreal for real-time playback, or merge off and take some of that and pipe it through another render distribution tool. Not sure what that looks like yet, but how do we take the pictures that are fast to create in Unreal, work on them with really high quality, really talented artists, push the picture even further, and then make it accessible to like a live stage scenario, like a live shooting scenario. I think that's something that I'll be curious to see happen as things move forward.
This is something Matt and I have talked a bit about, which is it's got to have 2D tools. We just do way too much. Compositors tend to say that the last 5% is 95% of the work. There's a ton of money spent on high budget films in that last 5% in compositing. So to have virtually zero 2D tools inside Unreal, just like he said, we need some way to push Nuke, not Nuke, but these things we can do in Nuke back into Unreal, or create this Nuke hybrid like we're doing with Genio, so that it is as fast as working inside Unreal. People use atmosphere in Unreal, but you can't do, as far as I can tell, you can hardly do anything with atmosphere like you can do with Z-depth compositing inside Nuke. So you just took off a huge part of my tool belt for look development by only being able to use atmosphere that's just a linear and a colorized fall off from camera, as opposed to garbage matting pockets, pushing black and white levels, and color contaminating things in a 2D manner. All these things you can't do, but you do all day long inside Nuke. So that's I feel the same way. There has to be a way to bridge the strengths of both, because right now people, I think, are a little bit confused at the beauty of the renders coming out Unreal, and they forget that that last 5% is 95%.
Yeah, I mean, one of the things that inspires us a lot in the building these types of pipeline tools and interop workflows is what we hear a lot talking to folks like you is the bringing lots of imagery and types of content from different sources to essentially, where Nuke's strength is, right? It's kind of bringing everything together and finessing and getting everything to play nice together, even if they're all from different tools and different renders, and being able to kind of calibrate and get everything all leveled out. Shahin, on Fireworks, for example, you had some stuff shot on an LED background and some stuff on a practical stage. And Matt, you recently introduced me to one of your friends was basically like, never mind game engines. Like a lot of the time we just want to go and like shoot footage and then be able to have that, go and running on LED screens in real time, like just, actually like, live plates. It's really about capturing, the interplay of the light and the actual people and the talent and the environment is what creates the seamlessness between the artificial and the real. Shahin, where do you think that direction is going to go? Like, are we going to see more blending of real-time, practical like film plates, 2D techniques? Are we going to go beyond the sort of like everything sort of like Unreal centric, and we just sort of work around the boundaries? Are we going to see more traditional film techniques kind of becoming more and more integrated into the process? And how's that going to work? Like, how do we work with with plates, LED screens, Unreal Engine, traditional lighting, all this type of stuff to kind of get a final result?
I feel like we've done a massive loop. We're going back to the 60s where we're doing rear projections, but now we're doing a sophisticated version of rear projections. The way I currently seeing the way things are heading in terms of Unreal production and LED screens, it is going to be a big factor tool in reshoots. Well, I mean, particularly at this point in time with the COVID thing that are going on, where you have practical set, you go into, and then you're going back to reshoots. Instead of relocating everybody back to another country, you can do a partial build set in this particular case, California, and have everything redone in Unreal and do that way. One of the thing is to recognize is that the virtual production you do on set is not going to be defined. It's basically a very sophisticated gaffer. You know, you're lighting the characters, and you still need to, because the inherent problem, well, it's not an inherent problem, it's inherent. The one thing you get from LEDs is lights bounce back. They do. The lights bounce back to the screen, and you lose your black levels. So you lose a sense of contrast unless you have a mad, ginormous LED screen. And that's where I think that the whole LED and practical shoot is going to head. It is going to kill a lot of visual effects shots, which were for some company, they were bread and butters. These are interior car shots. They're gone. When this evolves forward, they're gone. Green screen through a window, they're going to be gone. And another one that I had in my head was, face replacements. That's going to be the next one, where it will basically, we're talking about gravity at this point, which was the very, very early, virtual production where you're lighting the face, changing the camera wheel, bringing it back on. That's definitely going to have a big impact on deep fakes or the face replacement with using AI, where you will basically have a principal actor. You don't want to redo the whole set. You can have an LED screen, light it to this condition of the scan, and then reimpose it back to the actor. Those are the directions I think we're definitely heading.
I think that's really interesting because we hear, sorry, go ahead. This is probably really dear to what we're looking at in research as well. So I'm really curious what you have to say.
Feature.
Well, I think you said something. You said about, if I can loop back, you asked about, using plates and things like that. And I would just say to the folks at the Foundry is, if you build the tools where we can use photographic plates in a live production, we will use them.
I think it's,
the game engine, but I'd rather use photographic plates.
From my point of view, in the Foundry Research team, like, our focus is really on trying to build tools that help folks to scale, to have like orders of magnitude in productivity over periods of time. Like, we're really looking for things that are amplifiers, like force multipliers for artists. And looking at some of the things that Unreal can do is really great, but how do you scale that? I think that's kind of one of the challenges that always seems to come up, right? Like Indy, for example, like a lot of tools you're building are really kind of being deployed to large numbers of compositors within Pixomondo who make use of this day in, day out with like their familiar pipelines. How are you, I guess you must be pretty tuned into that in terms of like, how do I get all these compositors to like be productive without needing to go and all be, have to shift everything to this other tool. It can't possibly just be a yo-yo moving from one tool to another. It's really about the overall pipeline, and Pixomondo being, having a certain scale, it's got to really be a big consideration for your work. So how do you balance that?
These kinds of presets or tools, the things that you guys are building, which definitely helps people speed things up. Like, for example, the way Unreal built up presets in Movie Render Queue. We use that at Pixomondo while trying to extend multiple, like dozens and dozens of shots, where because I created the presets one time, now I can share them around and they're being reused by all the compositors. You just open it up, load it. It's becoming similar to how you would open up an Arnold file and then have the lighter already set all the passes up, which are already there, and then you just hit render and it starts rendering. So I feel like it is getting there. Unreal would be amazing as it slowly starts to become a DCC application rather than just a gaming engine. Similar to Blender, if you get the whole packaged in one software, and then have just the dedicated compositing software, which is separate, just because at the end of the day, there's a reason why Nuke is leading the industry in terms of compositing, because of the fact that not only has it been a part of the integral pipeline for a while now, but at the same time, it allows a lot more flexibility that you wouldn't find in any other compositing package from my personal use of different compositing packages.
Yeah. I'll take this chance to plug the inference mode feature, which is going into 13.1. So we've evolved, again, check out the Nuke session where we talk about this in depth, but we've given the ability for you to take a machine learning model off the shelf and kind of wrap it into the copycat infrastructure and run it through an inference node. So you can do crazy stuff like take cutting edge research-based machine learning models and try them out in Nuke, which is pretty neat. And like Shahin said, the possibilities for machine learning and how that's going to interface with other things like real-time technologies and things like that are going to be applied to practical use cases like reshoots or where locations are scouted versus where they're created artificially. And I find it really interesting that a lot of the focus on LED volumes and things like this are, a lot of stuff we see there for completely CG environments, but sometimes people just want to shoot stuff and have more kind of realistic environments and everything in between. What we've been so excited about is building better bridges, right? With tools like the Unreal Reader and this early days. So putting these bridges in the hands of folks like yourselves who are putting them to work in projects and just seeing what happens is really the first step. I think we can wrap it up. You guys have been really great. I really appreciate each of the projects you guys showed today and the time you took to talk about how you guys went through the execution of those, but also your thoughts on where this stuff is headed.
So there you go. Thank you everyone for sticking around through the panel. I hope you enjoyed it and found it interesting. I'd like to invite some of the panelists into the webinar so we can do some live Q&A. We'll be looking at the questions. You can post them in the chat, as a few of you have been doing so far. It'd be great to interact a little bit with the few remaining minutes we have. I just want to point out one thing. We did have some focus on Ari's amazing project, Small Blue Shadow, he's working on. Unfortunately, due to time, we had to cut some of that content from the video. However, we're trying to organize a deep dive on Ari's project at some point in the future. So keep an eye out for that. I've been really excited working with Ari, not just on his last project, Blues Crab, which is really great, but Small Blue Shadow, which also uses some great with Unreal Engine. Just want to say great thank you to Ari for that. So here's everyone. What did you guys think? I know it seems very different after it's all kind of edited and cut together, but I personally kind of seeing it play out after I'm just really interested by how there's a lot of alignment that the future is more complicated with virtual production, not simpler, and there's a lot of things to get a handle on. I know there have been a few questions in the chat about is Nuke going to have Unreal in it and things like that, and I'm always a little tickled by those questions because they're it's if we could put a game engine inside of Nuke and have everything in like one giant Uber tool, it would be great. Pipelines are subtle, and making everything work together is a subtle thing. I think that's one of the challenges you guys face day to day, and it's just really great to have your stories from the field. Oh, I have a question in chat about open asset IO. I can answer that. You guys are here to, you guys are here mainly for the real-time goodness, but open asset IO I think is something interesting as well. But yeah, open asset IO is a project going on in our cloud team that is essentially, if you look at all the applications that we use today, the way I put it pretty bluntly is they're all kind of stuck in the 1990s version of working with data. Like they open files on a disk, and that disk is like assumed to be physically attached to a machine. And if it's on network storage, you know, you can kind of fake that it's a immediate accessible file. But now, you know, going to the cloud, especially now everyone's kind of adapted to using some amount of cloud technology in their pipeline because of COVID, we realized that's not actually the way, that's actually the best way of working with data when it's distributed all over the place. We have things like object storage, cloud storage, things need to move around from place to place. And applications have never grown up into understanding that they need to have packaged things up together and ask politely when they want to get at a file that, you know, maybe they should ask an API that can go and resolve that. USD's been great. USD's got this asset resolver technology. Katana has this asset API. And the Open Asset IO project is a project that we're starting to very slowly open source. I think we're a few weeks away from actually opening up the GitHub repo for that, where we plan to connect that to not just our Foundry apps, but also some pipelines and tools, and hopefully make it an open source project that anyone can use. So when one of your applications asks for a file, it can ask for it through a URL or an ID, and Open Asset IO can go and take care of actually finding the file for you. And you don't have to go and write a different version of that for Shotgun, Frame.io, you know, your custom pipeline. You can all just, you know, go and use Open Asset IO. And by the way, we plan to support USD Asset Resolver. And the idea is to just kind of make that an open source thing that everybody can use, and then we can all move on to more interesting stuff. So I hope that answers the question. One thing no one's talked about is where Unreal is going with a lot of this stuff. Let me throw kind of a question out there with Unreal 5 and kind of see more capability. What do you guys think Unreal 5 is going to bring to the table? Is that going to be like an incremental thing, you know, for the way you work, or do you see kind of like this new generation of rendering technology in Unreal being a game changer more than just kind of more pretty pixels? I think it's a question a lot of people probably have in the back of their mind. I personally, you know, I'm a game developer from way back, so I'm always excited by that stuff. But I always wonder, how much is it a game changer versus how much of it is incremental? What do you guys think?
I can take that. Obviously, everyone's talking about Nanite because it's just mind-blowing. But my curiosity with Nanite is if it's, I don't fully understand it, but it seems like it's must be some type of voxelization and recreation, a conversion of the asset so that you can use such high poly counts. The question is, like right now, I've spent a couple of years trying to figure out all the I/O between other DCCs and Unreal, and it's pretty amazing how you can use what was created as a game engine but has been evolving into film and everything else. You've got a pretty good I/O system for almost anything at this point. But will Nanite be a stopping point because it's so proprietary, or will Nanite be able to still? Will they be able to bring? Will we be able to bring in assets, convert them to Nanite, and seems like you'd have to render everything in Unreal. So I just wonder if that's what that'll do. I'm curious what you all think.
Yeah, Matt, go ahead.
Yeah, please go ahead. You're good.
I was just thinking in terms of like the power of using original meshes. Like, yes, at the end of the day, it is some sort of technique to like hack the original mesh into triangles, clusters, which are relatively the same number when the camera moves. So the camera goes really far back, the number of triangles adjust. So overall, you never see a switch the way older LODs used to switch, because it would be the entire mesh switching at the whole time, and like you could tell immediately while you're playing the game or rendering a cinematic. But now having Nanite does that very carefully, but even then it's still like an optimization. And same goes for Lumen a lot of times as well, when yes, it gets you like real-time bounce GI, it's still some sort of hack where they're trying to do it. But to me, as a person trying to create art or cinematics in particular, that's my primary use case for Unreal Engine. I use it to create high fidelity cinematics. I think, yes, it might not be as accurate in terms of its capability, but at the same time, it would help a lot more because it is close enough. It's like that 90% of GI is there, and then like the remaining 5% you could get by pushing overall media render queue to take longer and compute and like render your cinematics out if that's your goal, which I'm guessing most of us are doing Unreal Engine for the goal of creating cinematics, more or less creating shots rather than actual gameplay. And as for like the proprietary part of Nanite, there are options where like obviously you have to bring your mesh in and then right click and then it turns your mesh into a Nanite. I wonder, I have the same question, if that technology would be able to be sent outwards into other engines at some point. But just to have the fact that even now we could just import like a ZBrush sculpt, because like I was just bringing in meshes and it was like not even sweating, like it was like at the same FPS and I was just duplicating like crazy. And like just 5 years ago, you would not be able to do that. Just having like massive ZBrush files in their original level of detail, no normal baking. So I think it is pretty game changer what UE5 came out with. It still has its bugs here and there, which obviously would get rectified when the official UE5 releases. But I think it's great for people trying to create cinematics.
And what do you think, Matt?
I think Indy summed it up pretty well. I mean, I think as far as virtual production and doing LED work, I think we'll have to wait and see. I mean, you've got different sets of issues there with playback and playback speeds and things like that. So there may always need to be a reason to optimize until the next video card comes out and it's so fast that we don't have to deal with that and we've got other issues. So I think wait and see, but I think for a lot of what Indy touched on, like the ability to bring something in from ZBrush, not have to deal with LODs and get all that fidelity right out of your model. Sounds great.
Yeah, one of the things we have one of the balls we have our eye on in research is, I'm a big geek for real-time rendering stuff, and I read the whole SIGGRAPH presentation that Epic did on Nanite. It's just really, really great, deep stuff. One of the things that really makes it tick that a lot of people don't realize is the high-speed interconnect between storage and the GPU, and the ability to stream these meshlets on demand. It's sort of like a new way of approaching lotting. There's lots of other tech like the occlusion tech and the meshlet generation, all that stuff is pretty advanced stuff as well. But a lot of that has prior art. The new kind of hardware technology around the high-speed interconnect and GPU direct and that type of stuff, I think opens the door to a lot more than just faster 3D rendering. That opens the door to real-time plates, playback, decode, streaming large amounts of 2D data and being able to composite things in real time. Things that haven't necessarily been explored as much because of sort of bandwidth and technology barriers between the different pieces of hardware required to process them. So yeah, we're quite keen on looking at that because that stuff's really opening up.
I would just like to add also to the fact that the technology also is mind-boggling, because a lot of people out here, including myself, used to think that when we downloaded the whole project, when UE5 launched, the test project was like 100 gigs. We thought that, like the future of any kind of content work is going to be massive because of the fact that people are now importing like large-scale meshes and you could just have millions and millions of polygons. I was surprised to find out when they explained and said out of those 100 gigs, like 80% or something is just texture files. The models only take like 5 to 10 gigs out of those 100 gigs. And like the rest of it is just textures on textures of just 4K and like any higher resolution texture. So I think it's pretty impressive to even have meshes that are that detailed, that hold up like within inches of the camera. like even be that close while streaming, as you mentioned, like the technology to stream that fast and to have that in a format that is very condensed.
That's interesting. As far as, I mean, being able to, then if that's the case if the models are that small, can we do more with procedural texturing
Yeah.
and rely less on texture? Ari, you work with Blue Sky. Didn't you guys use all procedural texturing on your projects, or quite a lot?
Yeah, quite a lot. I mean, I think for most of the history, it was all procedures.
Yeah.
But yeah. Yeah, I don't know. I mean, I look at a lot of this technology that they're doing, and I can desire, and others people can desire that interoperability with other DCCs. But in a way, you got to tip your hat to Epic in that they've created some technology that people are going to have to create something that replicates that technology. That's apples to apples, because some of it is so far beyond what other renderers can do. But if we were to shift the dialogue a little bit, one thing that's interesting to me about Genio Unreal Reader is that there's so much talk about real-time rendering, but very little talk about the fact that it takes a ton of effort, labor to get assets that are ready to render, whether it's real time or whether it takes forever to render. And so some of those tools, like propagation and foliage and LODs and these things that were born in the gaming system, and having those bridge over into standard VFX and animation pipeline. That's interesting to me, because I don't know how practical it's going to be to go from Unreal back if some things don't catch up to that. Everyone's going towards Unreal because it bridges both paradigms, game and film. But the film paradigm and the software developers, it's just looking at those game-centric tools and how we can bring those into film. Like I don't know how you do, but an LOD system inside Nuke. Like I was working with Unreal, and I created this like 2-mile stretch on the East River in Manhattan, and I had to create trees all along, and I had to create rocks all along it. And I did it the way I would normally do it. I put them in, and then everything slowed to a crawl. But I thought that there was certain anyhow, the short of it is that once I started using LODs, and once I started using sort of like texture LODs, I forget what they're called, everything freed up. And then I was working in real time with data sets that were infinitely larger than I could put into Maya or Nuke, certainly. So anyhow, it's that part before you get to rendering I think is almost more interesting to me, because a lot of the renderers have IPRs, which are relatively real for iterative look dev.
Yeah, that's great. And I for me personally, this is an exciting time to be working, just because of the convergence of these different tools. Are finally, game engines are nothing new, and none of these workflows are Unreal Engine, Unreal Editor. There you go. Yeah, this stuff's been around for a long time. It's just the popularity of it and the fact that it's kind of in the discourse is really great. So I don't want to take everybody's time, our very patient audience. You guys have been really wonderful. I just want to really appreciate everyone, you guys taking the time to share your work, to talk about it. This is the purpose of Foundry Live, our innovation panel, is really to talk about the future, and it's much more interesting to do it with smart folks like yourselves. So great thank you to you. Great thank you to the audience and the wonderful questions. Like I said, I hope to talk more about Small Blue Shadow, because I feel like that's a great project. I want to be able to talk about it a bit more in the future, because Ari, we've been talking about it for over a year, and it's really held my interest. So I want to wish you lots of luck in your work at Pixomondo. Matt Jacobs, lots of work, lots of success on your future projects. Shahin, if you're out somewhere, lots of luck in the future, and I hope Fireworks comes out and gets a lot of critical acclaim. And everybody take care, and hope you all have a great rest of your day.
Thank you.
Thanks,
Thank
man.
you. Thank you, everyone.